57. I've got 7 to the x equals 7 to the third. So x has to be 3.
Yay! Ooh, well, prove to us the 3 equals 3. Mathematically.
I think it is its own proof. That's the reflexive property.
Will wouldn't the reflection be an E?
Okay. For this one, I would like these both to have the same base.
So really, that's point. You do it like that.
Yeah. Well, this one. You mean square root of
Oh, yeah,
25?
yeah, that's okay, yeah.
Okay.
Yeah.
So this is, instead of 25, I could rewrite that as 5 squared.
Yeah.
All right. Okay, so it's better. Okay. So if I take this 5 and move it up here, what happens to the power on it, which is a 1?
So a negative.
So I'm going to have 5 to the negative 1 to the x. What do you do with a power to a power?
Multiply.
So this is 5 to the negative x. Now down here, if I do the same thing and I move this up here, 5 to the negative 2. So I have 5 to the negative x equals 5 to the negative 2, so x has to equal 2. Now this is another one where I would treat it like a puzzle and try to get it so that they both have the same base. So can I rewrite 16 so that it's 8 to the something?
No.
No, that's out. But can I rewrite 8 and 16 so that they have the same base? 2 to the something. So what would 8 be? 2 to the third. Isn't that still 8? Okay, so that's still going to be to the negative x plus 14 power equals, how do you rewrite 16? 2 to the fourth to the x. All right, well, when you have power to a power, so this is 2 to the 4x equals 2 to the what?
Negative 3x plus 3 times 14.
So 30 plus 12, that's 42. All right, so I have 2 to the something equals 2 to the something. So I really don't need the 2's anymore. It's negative 3x plus 42 equals 4x. Everything onto one side. Divide both sides by 7. And x is 6. Good.
We should write a strategy guide.
All right, first thing that I would do on this one is change that one. So,
E to the negative 2x.
right, so e to the x squared equals e to the 3x times e to the negative 2.
Now you can add those.
Okay, so when I put these two together,
E to the 3x.
right, we get to add their exponents. Now, because I have the same base, I don't really need the bases anymore, so it's just going to be x squared equals 3x minus 2. Get everything onto one side, and then factor. What makes this one 0? What makes this one 0? All right, on this one, optics,
Is that p times n?
p of n.
Oh.
So it's like a function.
Okay.
All right, so it says if a single pane of glass obliterates 3% of the light. Wow, that doesn't really obliterate it.
3%.
That's not what I think of when I think of something being obliterated. I'm going to destroy 3% of you. That's your big toe.
Less than that.
Of the light passing through it, the percent p of light that passes through n successive panes is given approximately by that function that they gave me there. So what percent of light will pass through 10 panes?
Just put it in the
So we plug a 10 in for the n and see what we get. Let's see.
Those ends are getting lucky.
Right, so when I plug that into the graphing calculator here, say I'm going to have 0.97 raised to the 10th, and then I want to multiply that by 100. And that's going to get us 73.7% of the light that we'll still have. That is not a percent sign. There we go. All right, and then for part B on that thing, you do the same thing except for 25 panes. I will spare you.
Yeah.
They gave us this formula for rumor spreading, right, where P, let's see, N is the number of people in a community college that have heard the rumor. P is the total population in the community D is the number of days that have elapsed since the rumor began. In a community of 1,000 students, how many students will have heard the rumor after 3 days? So what goes in for P?
Wait, are we taking into the 1,000?
1,000.
That Facebook is now open or not?
My guess is this was before Facebook because this would probably spread much faster.
Well, if one person posted, it's
Right.
X times infinity.
So 1,000 is what goes in there. 1 minus e to the negative 0.15, and then 3 days is what we're looking for. So basically, I just have to plug that into a calculator and see what I get. So negative 0.15 times 3. And then I want to go e to that answer. 1 minus that answer. And then times 1,000. Only 362.4 people. So I guess we'd have to round down so that we didn't have 0.4 per person. Because they're really short. That doesn't seem like very many.
There's probably some nerd that's like, I want to know who came up with this rumor. Who knows now?
Yeah, well, what kind of rumor is it?
Probably not that good if it's only spreading that fast.
3 days.
Like 100 people per day. All right, any other ones? All right. Okay, this one should bring back some fond memories for you guys, and it's short. So, win-win.
Yeah, this was on the ACT and I forgot.
How could you forget this? This is like one of your favorite things from last year. It's the loop-de-swirl. Right, so we have a to the y equals x. Right, and that's why I have a to the y equals my x. Right, so when I give you a problem like this, we would loop-de-swirl this. So my real problem is 2 to the y equals 16. So how can I rewrite 16 so that it's 2 to the something? So 2 to the y equals 2 to the fourth, so what's y?
4. Boom.
Right, now I can give you one here where I don't really have an equal something, so what do I make it equal? Make it equal y. And then we go 3 to the y equals 1 over 27. All right, so don't think of that as being a 1 over 27. Just look at the root number of it, 27. So can I rewrite 27 so that it's 3 to the something?
3 to the 3rd. I think. I don't know.
Yep. But I would like that to be in the numerator instead of the denominator. So it's 3y equals 3 to the negative 3rd. Good. How about this one then? Don't change your plan just because the thing inside the logarithm is more complicated. It's the same idea.
So 3 squared equals 4x minus 7.
3 squared is 9. Add 7. 16 equals 4x, so x is 4. Okay, what about when the base for my logarithm is a variable?
X squared equals 64.
Mm-hmm. Now what?
X equals 8.
Square root both sides, so x is going to be 8. All right, now what about this one? It is, so I want to go back.
So it's log of E.
Now we've done these before last year, but it's been a while. So if we act as if we've never seen the step, the easier step that I would immediately do to this problem, we have to work our way backwards from this thing. Now, first of all, it's an e, right? So when I have a log base e, we use something else. That's where we use that natural log, because the natural log's base is always e. Okay? So when I rewrite this one, let's see. So if I'm using this as my guide, right, and I have an a to the e, the a part is supposed to be my base. So that's this one. So I'd have a log base e. I'm going to rewrite this so that it looks right in a little bit. And then the exponent part is supposed to be what it's supposed to be equaling out here. So that's my 2x. And then we have my 5 has to go there. Okay. Now we don't write log base e like that. We write it this way. because we know that the natural log always has a base of e. You remember that from last year. Now the natural log of 5, that's just some decimal that I can get in my calculator. So we can type that in here. Natural log of 5.
So when that happens, you can always just skip that and go natural log of whatever it equals.
Yes.
Okay.
Essentially what we're doing here is natural logging both sides, which is what we did last year. I'll show you that step. I think it's what I end up teaching you guys tomorrow. Right, anyways, but so this is 1.6 equals 2x, and then what? X will come out to be approximately 0.8. This was approximately. Okay, so what we were doing last year with a problem like this, we go e to the 2x equals 5. Well, can I rewrite 5 so that it's e to the something? I can't, that's out. So what we end up doing is going natural log both sides. This got to move out in front. So I'd have 2x natural log of e equals natural log of 5. And if you type natural log of e into your calculator, do you know what that comes out to be? 1. So I don't need that anymore. So I have 2x equals natural log of 5. And that's where I am right here. So essentially by undoing the loop-de-swirl, we're really doing that step. But I think that's easier because it applies the properties. Now we haven't gone over the properties again yet this year, but we will soon. Probably tomorrow.
What was that it?
That's it.
Whoa.
Pretty easy stuff. Loop-de-swirling, your favorites.